Good morning, everyone. Welcome to our today's session. We're basically going through a case study here. It's a machine learning problem under predictive analytics, and we are trying to see how we can solve a problem using machine learning, first of all, to build a predictive model, or rather, a predictive model. Then after that, understand the results, being able to translate the results, and also going ahead to recommend actions based on the results. Yeah. So we have an institution by the name Connectel, which is a leading telecommunications company which operates in a highly competitive market. And they provide services like mobile, internet, and digital services to thousands of customers across the country. Over the last 12 months, Connectel has observed a steady decline in its active customer base, despite maintaining strong acquisition numbers. So they feel like they've been doing everything in the right way, but still they've been having a decline in its active customer base. So that is to mean customers have been leaving. An internal report shows that significant number of customers are leaving the company every month and switching to their competitors. Yeah. This increase in customer churn has started to impact. So it has an impact. One, monthly revenue, because if the customers are declining, then the monthly revenue will definitely go down. Customer lifetime value is also going down, and also marketing and acquisition costs. You can imagine they are high, but in return on investment is not making sense. Yeah. So the business challenge is that currently Connectel reacts to churn after it happens once a customer cancels their service. And this reactive approach means the company loses revenue before taking action. Retention efforts are poorly targeted. Then marketing budgets are spent blindly on mass campaigns. And management wants to shift from a reactive strategy to a proactive, data-driven retention strategy. Yeah. So being in the customer experience analytics team or being in the data science team, your responsibility is to analyze historical customer data, identify patterns associated with churn, build a predictive model that estimates the probability of churn for each customer, and then translate the results into actionable business insights for the retention team. So the data provided is, one, you're given a historical data set containing customer demographics. Those are customer details, subscription details. Remember we said they offer mobile, internet, and digital services, service usage information, billing and payment behavior. And we also have a churn indicator, showing whether the customer left or stayed. Whatever we're supposed to predict. Remember, we are trying to predict, or rather, we're trying to build a model that should estimate the probability of a customer churning or remaining. Yeah. So we also have in our data, we have that column that shows the churn indicator, whether the customer left or stayed. And each row represents one customer. So the primary objective here is to develop an end-to-end churn prediction solution that enables Connectel to identify high-risk customers and implement targeted retention strategies to reduce revenue loss. Yeah, so it has already been defined. We have defined the objective, the primary objective, which is one, we need to build a model, an end-to-end prediction solution. So it's a predictive analytics model that we are building. And from this model, we are supposed to be able to identify high-risk customers and also implement targeted retention strategies to reduce revenue loss. Remember, we said in data, anytime you have data or in data analytics is simply turning data into decisions, right? So we're supposed to use our data to make decisions. And that is what you're supposed to get from these predictive model that you're trying to build. I hope that is clear. So first thing first, you need to, the data has already been provided, yeah? So you need to understand the data that you have. What does it entail, yeah? So this is the data. And we need to know how many columns do we have here. So you highlight the first row, which has the column headers. So we have 21 columns. We have the customer ID, gender, senior citizen. So senior citizen, that could be a question of, are they a senior citizen or are they not a senior citizen? And of course, for such, it's based on their age. Yeah, most likely based on their age. We have a partner. Are they a partner or not? Do they have dependents? What is their tenure in months? What, in terms of services, have they subscribed for phone service? If they have, do they have multiple lines? Have they subscribed for internet service? If they have they subscribed for online security, online backup, device protection, technical support, streaming TV, streaming TV, streaming movies, and what type of contract is it? Is it a month-to-month or is it a one-year contract? How are they billed? Is it paperless billing? Payment method, how do they make their payment? What are the monthly charges? And what are the total charges? And now our churn indicator, have they left or are they still there? Remember, this is historical data. That is when we're talking about have they left or have they stayed? So those are the columns that you're looking at or the different aspects that you're looking at. So once you understand that, you also need to maybe check for those that are categorical, what options do we have? Yeah. So of course, for customer ID, that is the primary key. So it's a unique identifier. You want to understand under gender, we have two options. It's either male or female. Under senior citizen, we have 0 or 1, 0 for no, 1 for yes. I hope that is clear. Then under partnership, have they partnered or not? So it's either no or yes. Dependence, is it no? I mean, we have two options as well, no or yes. Tenure, this one is numerical in number, so it might not be categorical per se. Yeah. Then for phone service, have they subscribed to phone service? Yes or no? And if they have, we have a follow-up question. Do they have multiple lines or not? So we have no for someone who has subscribed for phone service, but they do not have multiple lines. For someone who has totally not subscribed for phone service, that is why we have no phone service. Then for yes, for someone who has subscribed for phone service and they still have multiple lines. I hope that is clear. Then for internet service, we have three options. We have DSL, we have fiber optic, and no for someone who hasn't subscribed for internet service. If you have subscribed for internet service, have you subscribed for online security? So we have no internet service. So no for someone who has subscribed for internet service, but they haven't gone ahead to subscribe for online security. And for no internet service is for someone who has totally not subscribed for internet service. Then we have yes for someone who has subscribed for internet service and gone ahead to subscribe for online security. I hope that is clear. The same thing for online backup. We have three options. No, so that is to mean they have subscribed for internet service, yes, but they haven't subscribed for online backup. For someone with the answer as no internet service, that is to mean they have subscribed, they have totally not subscribed for internet service. Then for someone who has subscribed, whose answer is yes, it's someone who has subscribed for internet service and gone ahead to also subscribe for online backup. Then we go to device protection. Under device protection, we have no internet service and yes. Yeah, so it's a similar concept with the online security and online backup. Then for technical support, still the same. No internet service, yes. So that is to mean these four aspects here. We also have streaming TV, we have streaming movies. These ones rely on if someone has subscribed for internet service. I hope that is clear. Then we go ahead to contracts. Under contract, how many options do we have? We have 3 options: month to month, 1 year, and 2 years. Okay. Then under paperless billing, so we have 2 options. Are you billed? Have you subscribed for paperless billing or not? So it's either no or yes. For payment method, we have a number. We have bank transfer, which is automatic, credit card, automatic, electronic check, and also mailed check. Yeah. Then for monthly charges, of course, this is numerical, so it's not categorical in nature. And also for total charges, it's also categorical. It's also numerical. And you realize, so for, say, our first client, their monthly charges are 29.85 and their total charges are 29.85. So whatever determines the total charges is definitely the number of months. Yeah, what is their tenure? What is their tenure? So of course, now for total charges is just a minute. So total charges is, of course, monthly charges multiplied by, you also want to look at, it's the tenure, and the tenure is in months. Okay, the tenure is in months. I hope that is clear. So total charges is a multiplication of monthly charges times the tenure, and the tenure is in months. I hope that is clear. Then we have the churn indicator, which is either yes or no. And this is what we are trying to predict for us to be able to avoid reactive strategy. I hope that is clear. First thing first, you need to understand your data. That is the first thing. What it entails, the different columns that we have. You want to understand, are they categorical or are they numerical, and so on and so forth. I hope we are clear up to that point. So we come back here. So remember, this is Python and it's a machine learning algorithm, or rather it is a data science problem. So how do we go about a data science problem? First thing first, we are doing it on Jupyter Notebook. You can also try and do it from Google Colab. Google Colab is just an online IDE. And it is an online version of Jupyter Notebook, but it's safer when you have a Jupyter Notebook. So first of all, you understand the problem that you're solving and its type. And for our case here, it's a classification problem. Why is it a classification problem? You look at what we are predicting. Whatever we are predicting, it's a categorical problem. Your answer is either no or yes. So that is why it is a classification problem, a binary classification problem. Binary because we have two options. It's either a no or a yes. I hope we are clear up to that point. So the first thing, in any machine learning problem, you're supposed to do what? Understand the problem, then go ahead and now import the required libraries. Remember, you're doing this in a new notebook, yeah? And you have to make sure you call in the functionalities that you'll be using during your analysis. So you have to understand, what do I need? What libraries do I need for that particular problem? So first thing first, we need to import the required libraries. Import the required libraries. That is the first thing. Even before we proceed to do, loading of your data, you need to now call in the functions. Yeah, and it's better when you're able to understand the problem that you're solving and the kind of, whatever is needed, whatever you'll be needing along the way. Okay. So number one, we need pandas. Why do we need pandas? Pandas is a library in Python that helps with data manipulation. Yeah. And in our case, anytime you're dealing with data or in data science, as long as data is involved, pandas has to come in. Okay, because you need to look at different aspects. First of all, you need to load in your data. And how do you load in your data? You use the pandas dot, depending with your what format. Is it an Excel file that you're loading in? Is it a CSV file that you're loading in? And so on and so forth. So pandas is very important. So first thing first, we're going to import pandas. And how do you import pandas? As PD. Now, this is an alias name. Why do we need to do that? Instead of us, because we need to reference pandas. If, for example, we need a functionality from pandas, we need to keep on referencing. Yeah. So for us not to keep on using pandas, we use PD instead. Yeah. It's easier to use pd.csv rather than pandas.csv. It makes your work easier. Okay. Number two, we have NumPy. NumPy is a NumPy is a library that is usually used when you're dealing with numerical functions. And for our case, we have seen some numerical functions there. The column on monthly charges and total charges, they are numerical in nature. So you might need to do some numerical operations here and there. So that is why NumPy has to come in. I hope we are clear. And how do you import NumPy? You import NumPy and its functionalities as NP. Again, why? That is, NP is an alias name, yeah? Instead of using NumPy in full, we use NP. It's going to be easier for us to keep referencing using NP dot and so on and so forth, okay? Then we proceed to, remember in data science or in data analytics, visualizations are very important. And visualizations come in handy on the EDA stage, the exploratory data analysis stage, where you just want to understand your data. While doing the descriptive analytics, so you want to understand your data, and you understand your data better when you use visualizations. So for us to use visualizations, we have the library that we use. There are two. We have matplotlib.pyplot, and we also have Seaborn. Seaborn is built on matplotlib.pyplot. Matplotlib is the basis of visualizations, or rather it contains the basics of visualizations in Python. But if you want to do some more advanced visualizations, you can use Seaborn. Okay, so these two here, they're supposed to do what? They're supposed to help you when it comes to processing or generating data visualizations, right? So matplotlib.pyplot, its alias name is PLT. You can imagine how strenuous it can be when you use the entire name matplotlib.pyplot. So we use PLT. Then Seaborn, its short form is SNS. Yeah, its alias name is SNS. I hope we are clear up to that point. Then we now proceed to a model. Remember, we are building a model, yeah? And this is a machine learning algorithm. Anytime you're building a machine learning algorithm, you get your functionalities from a library called sklearn. sklearn, okay? Then from the sklearn, you can get the, the specific functionalities. For example, we need to split our data. So when it comes to modeling or building a model using a machine learning algorithm, first of all, you need to split your data. Remember, we are building a model based on the data that we have. So we need to split our data into training data set, the one that is going to help us build the model. Then now for us to evaluate the performance of that model, we need to use test data. I hope we are together. For you to be able to build a model, you use the training data. For you to be able to split your model, to evaluate your model, the performance of that model that you built, you use test data. And that is why we use the train test split. So where do we get the train test split? We get it from sklearn, the sklearn library, and the third we have model selection functionality. So from sklearn.model selection functionality, we want to import train test split functionality specifically. I hope that is clear. Number two, we need to, from sklearn.compose, import column transformer. So this one is going to help with transforming when it comes to data transformation, it's a part of the data preprocessing stage. Yeah. Then we also need, still under data preprocessing, we need to transform transform our columns into the right format for it to be used by a machine. We want to translate our data into a language that can be decoded by the machine. And that is why we need to, we use the one-hot encoder. That one is used to transform categorical type of data, while standard scalar is used when you're using numerical data. So standard scalar is going to help with standardization, just making sure that your data is in a standard range. It lies between a standard range. Yeah, while for one-hot encoder, it transforms categorical, it transforms categorical type of data into a language that can be, decoded by the machine. Okay. Then we have from sklearn.pipeline, import pipeline. Then we go to now the different metrics. So while we are evaluating our model, we usually use metrics or measurements. These are performance measurements. Yeah, so we have a number because you cannot use one performance metrics to measure the how effective or how good your model performed. So we have quite a number, then we compare. So we have the confusion matrix, we have a classification report, we have the ROC and AUC score, then we have the ROC curve, We have the precision recall curve. Those ones help with accuracy, precision, and recall. Then from there, you'll be able to interpret the different metrics and what they mean. Yeah, you basically need to interpret that. Then now, depending on the model that you're building, for us, you've said it's a classification problem. And classification problem, we can decide to do a regression algorithm, but the regression algorithm that supports a classification problem is the logistic regression algorithm. Okay, so where do we get that? Still from the sklearn.linear model, we want to import functionalities around regression, a logistic regression. Then number two, we are going to compare two models. We're going to also use random forest. And where do we get the random forest? Random forest, we get it from Ensemble, sklearn.ensemble. Ensemble is where you use a number of models, they are combined, then you can now compare their performance. Yeah. So from Ensemble, import random forest classifier. Then from sklearn.dummy, import dummy classifier. Right? So those are the libraries that we need from loading your data to pre-processing your data to modeling your data, evaluating your model so that we can run the full pipeline end to end. And I hope that is clear. So we proceed to, once we have imported the libraries that are required. So I'm going to run that cell. We can now proceed to loading our data sets. Okay, loading our data sets. And just a minute, even as we load the data set, I need to data, just a minute. So welcome back. So first thing first, we need to load in our data. How do we load in our data? So first of all, our data is in an Excel, it's a CSV file that has already been provided by the name ConnectTel Customer Chan. Sorry, and how we load in, we have different ways of loading data in Python. And there's the one that looks a bit safe where you just need to copy the path and paste it on, you just copy the path, then it's going to locate where the data is. Yeah, so first thing first, we give our data a name. We give it a name by the name DF. You can use, you can just use any other name, yeah, any name of your choice. So DF equals to, how do you load in data in Excel? How do you load in data in Python? We use PD. Remember, we talked about pandas, which helps with data manipulation. And under data manipulation, we have what? We have, that is inclusive of data loading. How do we load in? So it's pd.read. What are we reading? It's a CSV file. That is why we are specific with this. If it was an Excel file, it could have been pd.read_Excel. Yeah. Then you copy the path. So this is where my data is. This is my data. So what I have done, you select this, then copy path is going to be activated. You copy that path and then come and paste it inside these brackets as it is. And of course, it should be under the quotation marks. Yeah, so it's going to help load your data. So then we can run that. Yeah, so if we don't have an error, that is to mean our code has been successfully, or rather our code was correct. Yeah, so the next thing is now we go ahead and explore our data, and that is what we call exploratory data analysis. We want to explore our data, understand a few things here and there, including the shape, The shape is how many columns do we have, how many rows do we have, or rather, what is the size of this? What is the size of this data? We also want to check the information. What details do we have? How many columns do we have? I know we had done that using, while we were going through the Excel file, but now using Python, you want to understand in depth, how many columns do we have, how many entries do we have, and so on and so forth. Yeah, so we have loaded in our data. We now go to EDA. Under EDA, first thing first, we want to get information about the data. And the function that is used for getting information about the data is the .info. The .info function, it's going to give us details about the data. And what details do we expect here? The number of entries. What is the size of our data set? How many columns do we have? How many rows do we have? And then it goes down and lists down the columns that we have and their data type. And also you'll be able to tell how many missing values that we have in our data. Okay, so I'm going to run this. So this is df.info. So I'm going to run this code. And when you run that code, this is what you're going to get. Data columns. How many do we have? So first of all, range index, we have 7,043 entries ranging from index 0. In Python, we start with index 0, not index 1. Index 0 to index 7,043. That is to mean we're going to have a total of 7,043 entries. How many data columns? 21 columns. So it lists down the columns. We have customer ID. How many do we have? How many entries? 7,043 entries. They are non-null objects. So that is to mean we do not have any missing value in that particular column. Gender, the same thing, 7,043. Partner, 7,043. Dependent, 7,043, and so on and so forth. And what are the major data types? So under D type, that is where we have major data types. So we have object, we have integer, for those that have been recorded in as much as they are categorical, but they've been recorded as integer because they are numbers 0 and 1, if you can recall. For partner, it's either yes or no, so that one is taken as an object. Then tenure, it's integer because it's numbers. Then the rest, which were categorical, no yes, no internet service, those ones are object. Then for monthly charges, because they have been, we have decimal places, that is why we have float data type. For total charges, it has been recorded as object, but it should be a float data type. That is to mean there should have been a formula there. Yeah, a formula that this one has been calculated from multiplication of monthly charges times tenure, and our tenure is in months. How many months? So monthly charges times the number of months. Then under churn, our indicator, churn indicator, remember it was either yes or no, which is a categorical type of variable. So that is, at least you have details about your data. Then we go ahead and look at the size. So size is basically how many columns do we have, how many rows do we have, and total number of entries. So how do we go about that? We use the .shape method. .shape method. Something that I want you to realize is that we are referencing our data set. What was the name of our data set? DF. And what do we want to get from DF? So we want to get the shape, the size of the DF, which is, so it's df.shape, then it's going to give us the number of columns and the number of rows. So I'm going to run this. Oh, sorry about that. Once you run this df.shape, it should give you, so we have 7,043 columns, rows. We start with rows followed by columns, and 21 columns. I hope we are clear up to that point. Then we now proceed to general summary statistics. Even before we proceed to doing, analysis after we've changed our data, we want to do some general statistics just to understand what can we get, what information can we get from our data as it is before we go to data cleaning. So how do we do that? We use the dot describe function. The dot describe function helps you to get summary statistics. And what is summary statistics? That is counts. How many entries do we have in this particular column? Number two, minimum number, maximum number, the range, the average, the median, the mode, and standard deviation. Those are some of the summary statistics, such that you can just give a brief report of this is what we got, especially if your data, you're so sure that your data is clean. From summary statistics, you'll be able to give, well, not something, or rather you'll be able to describe how your data looks like. Okay, so we're going to run that code, or rather run that cell df.describe. And what does it give us? It gives us what we have, the details. And you see, it gives us details about our data. And the reason there is not much calculation is because most of our data here is categorical, right? Categorical. That is why we have such. So it has just given us a brief description of what we have, okay? Once we are done with that, we can now go ahead and maybe check for missing values. It is now we get to the data cleaning process, but before we get there, we need to check. Do we have any missing values? Do we have any inconsistencies? Do we have any duplicates? So those are some of the things that we look at. And I think we're going to start from there in our next session. So up to that point, maybe you can try that on your side, then we'll be good to go. See you in our next session.